You know, when we think about high-tech automation, our minds usually jump straight to the flashy robots and the complex machinery. But what about the nervous system holding it all together? Let's dive into connectivity, because it is so much more than just a bunch of wires. It's a complete ecosystem. So let me ask you this. What's the weakest link in your system? You could have the most advanced, multi-million-dollar operation, but you know what? It can all grind to a halt because of one tiny overlooked component. And that's really the core of what we're talking about today. And here it is, the main idea. Your connectivity layer isn't just an accessory, it is the operational backbone. It literally dictates how reliable your system is, how long it's going to last, and what kind of maintenance you're going to be stuck doing. So these choices, they're not just details. They're fundamental to your whole operation. The stakes are incredibly high. So let's start by giving connectivity the credit it truly deserves. It's the unsung hero, right? It's that complex web of nerves carrying all the power, the data, and the signals that actually bring a machine to life. And when that hero goes down, the consequences are, well, they're massive. We're talking about catastrophic, unplanned downtime. Every single minute that line is down can cost you thousands, maybe even tens of thousands of dollars. And it could all be because of one single faulty connection. That's the exact risk we're trying to design out of the system. So, where do you even begin to build a truly reliable system? Well, the foundation might not be what you think. See, your first line of defense against failure isn't some fancy software or a new sensor. It's the physical material of the cable jacket itself. And listen, not all cables are created equal. It's like you wouldn't use the same tool for every single job, would you? It's the exact same idea here. On one side, you've got something like PVC, which is a great, cost-effective choice for standard, stable environments. But on the other side, you've got a material like PUR, which is specifically engineered for the intense, constant motion you see in robotics. In fact, there's a whole portfolio of these materials, and each one is designed to solve a very specific set of environmental challenges. You've got everything from that versatile PVC to the super resilient FEP for harsh chemicals, or even FRNC, which stands for flame retardant non-corrosive, for places where safety is the absolute #1 priority. Honestly, you can think of this table as your cheat sheet for matching the right material to the machine's environment. Is it a pretty standard fixed application? PVC is your guy. Is it a robot arm that's twisting and turning all day? Well, then you need to be looking at PUR. This is how you design reliability in from the very ground up. Let's just zero in on Pure for a second because it is a perfect example of this purpose-built engineering. It was specifically designed to handle the highest stress failure points in all of automation, those articulated robot arms and the constant back and forth motion of drag chains. And the reason it works so incredibly well is its resistance to all the hazards you find in those environments. Things like weld sparks in an auto plant or the constant twisting stress on a 6-axis robot. So choosing PUR here isn't just about a material spec. It's a direct strategy to increase your mean time between failures. You're keeping the line running longer. Period. Okay, so we have the right material. But a super strong cable is totally useless without an equally reliable connection. And that brings us to our next point, the power in the connection itself. The whole strategy here is about one thing, eliminating human error. So instead of having someone wire connectors by hand out in the field where anything can go wrong, you use factory-molded, pre-tested cord sets. This basically shifts the burden of quality control from the installer to the manufacturer, which drastically cuts down on failures from bad wiring. And the amount of power these connections can deliver now, it's a total game changer. We are talking about 16 amps of current delivered through a connector as small and as common as an M12. I mean, that's a huge amount of power in a tiny little package. So why does that matter so much? Because it lets you get rid of those massive centralized control cabinets. You can now deliver serious power directly to components out on the machine, which lets you design smaller, more modular, and way more flexible systems. All right, so we've covered the physical layer, the materials and the power. But modern connectivity isn't just about volts and amps anymore. It's about data. It's about building an intelligent system. And the key technology that makes all of this possible is called IO-Link. The easiest way to think about it is as a universal language. It allows all of your sensors and actuators to talk digitally to the machine's brain, the PLC, all over a simple standard cable.
And the setup is beautifully simple. Your smart devices, they just connect to a local hub. That hub gathers up all the signals and then sends them back to an IO-Link master. And that master translates everything for the main controller. It's just a really clean, scalable way to get all that data from the field. What this unlocks is really transformative. Setting up the system becomes way faster with features like auto-config mode, but more importantly, you're not just getting a simple on or off signal anymore. You're getting rich digital data, diagnostics, status updates that can feed into predictive maintenance systems and tell you about the health of your machine in real time. Okay, let's pull all of this together now. We've looked at materials, we've looked at power, and we've looked at intelligence. And the key thing to remember is that none of these are isolated choices. They are all pieces of a single overarching strategy. When you start looking at connectivity this way, it changes everything. Choosing the right material isn't just buying a cable anymore. It's a risk mitigation strategy. Using high-density power isn't just a wiring choice. It's what enables modern machine design. And using IO-Link, well, that's deciding to turn your wiring into a source of incredibly valuable operational data. At the end of the day, every single decision we've talked about comes back to these two goals. A well-thought-out connectivity ecosystem directly translates to less downtime, higher efficiency, and a system that's robust, intelligent, and ready for whatever comes next. And that's really the question I want to leave you with. Take a hard look at your own systems. Are you treating your cables and connectors like simple, off-the-shelf parts? Or are you leveraging them as a core part of your strategic plan for reliability and performance? Because that difference is everything.